how to form a PDE by elimination of the arbitrary constant. The question on the board says we should form a PDE from Z is equal to y to the power of 2 plus 2f into 1 of x plus log y. In this given relation or equation, how can we form a PDE? Remember, I have explained the way we form a what PDE by what elimination of the arbitrary function, whereby we are going to we're going to take our partial differentiation into what into second order. Then from the second order, we form a PDE from the second order. I'm going to differentiate z with respect to x partially, z with respect to y partially. So let us consider the steps. Solution to this: z is equal to y squared plus 2f 1 over s plus log y. I differentiate, I make this one, I will let this one to be equation 1, then differentiating partially with respect to x in equation 1. I differentiate equation 1 with respect to x. If I differentiate z, I'm going to have partial z over partial x because I'm differentiating with respect to x. So I'm going to have the z over the x. So if I differentiate y squared with respect to x, you can see that y squared is not affecting with x. Whenever I differentiate y squared, because it's not s, I'm going to consider it as what? As a constant. Whenever I differentiate constant, I'm going to have 0. So here is 0 plus. Let us take 2f. I'm going to take 2f. It's a product. I'm going to differentiate all this. If I differentiate all this, what am I going to have? If you remember in our first example on how to form a PDE, the problem we did there is that the best way to solve this with respect to each value we are given is that we are going to differentiate this, then multiply it together, then this f is going to have f prime. So I can use chain rule to solve this as well. But before I consider chain rule cannot go in 1 over x. The reason why the chain rule cannot go in 1 over x is what? 1 over x is a fraction, and I'm differentiating partially with respect to what? With respect to x. That means I'm going to what? I'm going to apply a quotient rule to this. Remember, when you have a numerator and denominator, if you want to differentiate, we apply what? Quotient rule. So from this one, let us say I have 2f. Let's say I have 2f 1 over s plus log y. I have something like this. So it means for me to solve this one, I'm going to differentiate 1 over x first with respect to what? I'm going to differentiate this with respect to x. So this one will be considered as u, this one will be considered as v. So what I'm going to do here is what? I'm going to differentiate, I'm going to use quotient rule, which is what? V du over ds, V du over ds minus u dv all over ds all over v squared. This is what I'm going to use because I'm differentiating partially with respect to x. So let's take v, our v is x, du over ds, let us differentiate numerator with respect to what? X. 1 is a constant, I'm going to have 0. Minus, let us take u is 1. Let us differentiate dv over ds. So the denominator with respect to x, I'm going to have what? 1. All over what? V square. Our v is what? S. S is power of 2. S times 0, I'm going to have 0 there. Minus 1 over what? S square. You can see that when I differentiate 1 over x here, what do I get? I get minus 1 over s square. So it means I'm going to, if I take this one, 2f, differentiate all this one with respect to x, I'm going to have minus 1 over s square. But if I differentiate this one back, so this minus 1 over x is going to multiply this. So I'm going to have 1 all over x, 1 all over x plus log y. If I differentiate f, I'm going to have 2f prime plus, then I differentiate this one, 1 over s. What do I get? I get multiply by what? Multiply by minus 1 over what? S square. So that is it. What I did there is what? I cannot if I differentiate log y, I'm going to have 0 plus what? Plus 0. Plus 0 because log y is not a function of x, it's a function of y. Then if I'm considering x with respect to y, which is constant, which is what? 0. So that's why I have 2f. If I differentiate this function, I'm going to have 2f prime. I have differentiated f here. I have 2f prime with everything. Then multiply by what? If I differentiate this one, what am I going to have? Minus 1 over s squared plus what? Log y plus 0. So remember that our notation for del z over del ps is what? Is always p. So I'm going to have p is equal to 2f prime multiplied by this one. I can have 2f prime all over what? S square. Here will be minus. If I say 2f prime multiplied by this one, then multiplied by what? 1 all over s plus log y. So I multiply this with this. So that's why I have this. So the next is what? To differentiate. I can name this one is equation 2. Next what? To differentiate equation what? Equation 1 again with respect to what? With respect to y. So I'm going to have differentiating equation 1, differentiating partially with respect to y. With respect to y in equation 1. So if I differentiate z with respect to y, I'm going to have partial z over partial y is equal to. So if I differentiate y squared with respect to y, I'm going to have 2y plus if I differentiate 2f prime. So if I differentiate f, I'm going to have 2f prime, then multiply by 1 over s plus log y. Multiply by what? I'm going to differentiate this one over s, that is 0 plus, because 1 over s is not a function of y, so we are going to consider it as what? A constant. Whenever you differentiate a constant, you are going to have 0. If I differentiate log y here, I'm going to have what? 1 over what? 1 over y. Log y is what? Then y. So whenever I differentiate log y, I'm going to have 1 over y. So in this case, what do we have? Our notation for the z over the y is q is equal to 2y plus this. I'm going to have 2y plus 2f prime 1 over s plus log y plus 0 plus this. I'm going to have multiplied by what? 1 over y. Q is equal to 2y plus 2f y all over s plus log y all over minus y. So next one, I can take my 2y to the left hand side. So I'm going to have q. I want to rearrange. I'm going to have q. I'll be left with q minus 2y. Q minus, I will take 2y to here, to the left hand side. I'm going to have q minus 2y is equal to, what do I have next? I have 2f prime 1 all over s plus log y. Multiply by what? 1 times y. So 2y over y, so I can have 2f prime over y here. Because 1 times numerator, I'm going to have this. The denominator is over y. So I can name, I'm going to name this one as equation 3. What's my next step? My next step is what? To compare equation 2 and equation 3. Like, is there something related to each other? Can they cancel them out? So if you check equation 2 and equation 3, you can see that f prime 1 over s plus log y, this one is common to this. This is equation 2, equation 3, equation 2. So we can say we can divide equation 2 by equation 3. So let us divide equation 2 by equation 3. The reason why we are doing that is what? We want to cancel out the arbitrary function in this given equation 2 and 3 so that we can form a new partial differential equation. And the best way of doing that is what? To divide equation 2 by equation 3. You cannot add it together. If you add equation 2 by equation 3, it means that what? We are adding our arbitrary function into again. But we want to remove what? A constant. It means what? We have to what? Divide equation 2 by equation 3. So let us divide equation 2 by equation 3. What are we going to have? Divide equation 2 by equation 3. So what am I going to have? 2 f prime 1 over s plus log y over s square q minus 2y 2f prime over y 1 over s plus log y over y. So you can see that 2f prime 1 over s plus log y is common to each other. You can easily cancel them out. This is going to cancel this. 2f prime cancel the f cancel this, the f prime will cancel this as well. 2 is also here, 2 will cancel this. So what are we left with? We are left with what? P all over q minus 2y is equal to what over s square over y. I can take this one to here. So I'm going to have P all over what? Q minus 2y is equal to, I will take y to the numerator times 1 times y all over what? X square. So I'm going to have left is what? P over Q minus 2y is equal to what? Y all over what? X square. The next step is what? I've removed the what? Arbitrary. Remember that here we have minus 1. Remember that here, what do we have here? We have minus 1 over x square. So it means our P here is minus 2f prime. P here is negative here. So we have negative here. So it means here will be what? Negative. Here will be what? Negative. So I'm going to have minus 1 here. So negative. So we multiply this one with this one. I'm going to have q minus y times q minus 2y multiplied by what? Minus y. So I will left with what? Ps square p s square is equal to minus y times this. I'm going to have minus qy plus what? Plus 2y. So what you can do, I can take minus qy to the left hand side. I'll be left with what? Ps square plus qy is equal to what? 2y. 2y times y, 2y square. 2y square. Which is the required PDE? Which is the required PDE? Which is the required PDE? It means I have eliminated the arbitrary function, whereby I get my answer as what? Ps square plus qy is equal to what? 2y square, which is the required PDE. There's a negative here already, so that's why we have negative here. So minus 1 over x square over y. So minus 1 times y, I'm going to have minus y. Then I use this minus y to multiply qy. I got minus qy. Then I use this minus y to multiply minus 2y. I got plus 2y square. I take this one to the left hand side. Minus will change to what? Plus is equal to y square, which is the required PD. It means I have eliminated the arbitrary function. So this is my answer to the given problem. It means I have eliminated the arbitrary function, whereby we get a newly PDE to the solution. I hope you find it interesting. Thanks for watching.